So we're going to graph and find the vertex, axis of symmetry, x-intercepts, y-intercept, domain, and range for number 4. Y equals negative 2x squared plus 3. That is a parabola because it's a quadratic. And there's no linear term, so it's just an x squared shifted up 3. So we're going to go up 1, 2, 3. Then because we have that negative, we know that it opens down, meaning that it has a maximum. And it's not the 1, 3, 5 rule. We're going to take that, we're going to multiply by 2, and it's going to become a 2, 6, 10 rule. Because it's opening down, we're going to go left 1, down 2, right 1, down 2. Left 1 from here, left 1, down 1, 2, 3, 4, 5, 6. Right 1, down 1, 2, 3, 4, 5, 6. Now the axis of symmetry, you can see it. We've got that symmetry happening that goes right through the vertex. So the axis of symmetry, which goes right through the vertex of 0, 3, the axis of symmetry is x equals 0. The vertex, I'll write that too right here above, is 0, 3. The x-intercepts, the x-intercepts are going to be a little tough because they're not exact lattice points. Those are negative 1 point something and positive 1 point something. So we're going to have to do a little bit of work there. Our y-intercept, so I'm going to leave space here. We've got 2 x-intercepts. You can see them. We've got 2 x-intercepts right here, but we're going to have to do some calculations. Our y-intercept is where the graph crosses the y-axis, and that's happens to be through the vertex at 0, 3. The domain continues to the left and right forever, and the range is negative infinity to a maximum value of positive 3. So negative infinity to positive 3. Okay, so let's work on those x-intercepts. The x-intercepts are the solutions. So I'm going to put a 0 in for y. They're the solutions. They're the value of x when y is 0. So we're going to put a 0 in for y and solve. I'll add 2x squared to both sides. I have x squared equals 3 over 2. I'm going to square root both sides, and I get x equals plus or minus the square root of 1.5. And the square root of 1.5 is going to be about 1.2-ish. You can put that in your calculator and you can check. But I'm going to go with 1.2-ish. So negative 1.2-ish and positive 1.2-ish. So let me write that so that you can see it. Negative 1.2-ish and 1.2-ish. And that's how we find that. Okay, number 6. Find the vertex and the axis of symmetry. Y equals negative 3x squared plus 12x minus 2. The vertex is the opposite of b over 2a, f of the opposite of b over 2a. So we're going to have, I'm going to have to do some work here. We're going to have the opposite of 12 over 2 times negative 3. So that's going to be a 2. So we've got 2. Now I need to put that 2 in to the function. So I have to put that 2 in for the x value and compute the y value. So I've got negative 3 times 4 plus 12 times 2 minus 2. So negative 12 plus 24 minus 2, that's 12 minus 2, which is 10. So the vertex is 210, and the axis of symmetry is x equals 2. Number 7, I'll finish up with number 7 here. Identify the vertex, if it's a maximum or minimum, what that value is, and then the domain and the range. So I've got y equals 1/3 x squared minus 9x. So I'm going to have the opposite of b, so the opposite of -9 would be +9 over 2 times 1/3. So that's going to be 9 divided by 2/3. 9 divided by 2/3 is the same thing as 9 times 3/2. So the first value is 27 over 2. I'm going to put a 27 over 2 back in for x. So I've got y equals 1/3 times 27 over 2 squared. So I don't have my calculator, so I'm just going to do that. 27 over 2 squared minus 9 times 27 over 2. So I've got 9 times 27 over 4. So 9 times 27. This one's a lot of work without a calculator. I hope you're using a calculator. I'm getting 243 over 4. 243 over 4 minus 243 over 2. So I need another 2 there. And I'm going to end up with, I know exactly what I'm going to end up with. I'm going to end up with 243 over 4, a negative. So that's going to be negative 243 over 4. So this is not a lovely problem whatsoever. You can use your calculator though, and you might get decimals, and that's fine with me. As long as you understand the concept, this is the vertex, and they want us to find the vertex. Because A is positive, it opens up, meaning I have a minimum. So my minimum value is equal to negative 243 over 4. Okay. The domain is always negative infinity to positive infinity on the quadratics, and the range is going to be negative infinity. Nope, so sorry. This is a minimum. So it has a minimum, right? So I'm going to have a minimum, comma, infinity. So the minimum value is negative 243 over 4, and that goes to infinity.